So with that, I'll pass it along to Franco.
Hey everyone, thank you for joining us today on another episode of Data Collab Lab with Franco and Denny. Thank you, Karen, for introing us and kind of sharing all that awesome new news. Malcolm Gladwell, I am super excited that he's coming to Data and AI Summit. Outliers has to have been one of my favorite books out there, so I am super excited that he's coming. And I'm joined here by a couple of my favorite outliers, Will Girten and Soham Bhatt, and Denny Lee. And we like to kind of show you what's going on in Databricks land. And something that happened recently, Will created this new project, and Soham and I kind of saw what it was, and we got super excited. So Denny and I were talking about it, and they're like, maybe we should bring them on the lab. And so what do you think, Denny? Does that sound like a good idea?
I don't know. Yeah, you're right, actually. No, I'm joking. Of course, it was a great idea.
Awesome. Will, you want to introduce yourself, kind of who you are, where you are, and what you do for Databricks?
Yeah, sure. Hi, Franco. Hi, Denny. So my name's Will Girten. I'm an RSA at Databricks. I'm currently based out of New York, and basically what I do, because of my background, I work with some of the largest federal customers at Databricks.
Awesome. Thanks, Will. Soham, you want to introduce yourself, who you are, where you are, what you do at Databricks?
Yeah, sure. Hey, everyone. My name is Soham Bhatt, Solutions Architect with Databricks, based out of Seattle, Washington. It's getting cloudy and rainy here again, but the summer and fall were beautiful. My background before joining Databricks was a big data platform architect at Toyota Motors. So I come from a lot of data lake, data platform background, and before that I did a lot of ETL and built a lot of data warehouses for various companies. So excited to be here.
That's awesome. Thanks. So Will, you work with federal customers, huh? That's pretty important work. You probably can't say a lot about what you do, which we got to respect those boundaries. But a little known fact I know about you is that you have some type of secret clearance. Is that right?
Can't say.
All right, fine. Denny and I are going to run a visual AI algorithm on these frames afterwards. We'll find out.
Sweet.
That's right.
Awesome. So let's get into it. First, I'm going to just share my screen and kind of show you a notebook that we've been working on, and then we're going to talk to Will and see kind of what this is. What is Hyperloop? So, Will, you want to take us there? What is Hyperloop? How did you even think about this? And kind of what were your initial findings? And kind of just tell us like the origin story.
Yeah, sure. So Hyperloop is a library I created. So basically the problem that it solves is, yes, it's just another library that you can download and install. But say that I'm a Tableau user, and basically I come in and I want to do a new visualization. So all my data lives out in the Delta Lake, and I want to build my report basically off that data. In order to do that, I fire up my Tableau desktop client. I use the brand new Tableau connector to Databricks cluster, and then I begin my extract. And then I wait. And I wait, depending on the size of the extract, I might be waiting around for a very long time, on the order of maybe several hours even. Or, say that I know that my data set's pretty large. There's millions of rows. What I could do is basically schedule that extract as a job within Tableau Server and have that job run overnight. And then, basically I want to capture the latest data as it changes up in that Delta Lake. I could set that job to refresh. But over time, as my reporting team grows in size, there might be more and more people running these extracts that pull the data out of the Delta Lake and create a Tableau extract. And over time, what happens is basically the Tableau backgrounder can't keep up. Long-running extracts jobs take a long time, and they basically queue up over time. And pretty much the Tableau backgrounder can become a single point of failure as resources get exhausted. So what Hyperloop basically does is it solves that waiting around problem. So rather than pulling data out of the Delta Lake across ODBC, which can be a pretty chatty protocol, what it does is instead of pulling it, it kind of does the inverse. So we create a data extract from the Databricks cluster as the data changes within the Delta Lake, and then we push it rather than pull it. So at the end of the day, it basically under the covers, it uses the Tableau Hyper API and Hyper format and then basically does a file transfer rather than an ODBC connection.
Huh. That's interesting. So basically, it's on the Tableau side, it's a pull versus a push. I'm sorry, it's a push versus a pull, which
Correct.
could actually lead to better architectural patterns.
Yeah. So in general, as far as scale goes, it allows you to basically scale out your extracts a lot easier, and also to be able to run them a lot more frequently. So you're able to build a lot more accurate reports and visualizations off the latest data as you perform the CDC on your Delta Lake. So you get a lot more data, a lot faster.
That's interesting. So when you created this and you first started telling kind of the field about it, I know Soham and I were super interested. Soham, how did some of the people you were working with initially react, and how has it been going so far?
Yeah, they were super excited. I mean, first of all, when I found out about this pattern of Databricks actually creating the Tableau extracts and pushing it into Tableau, I'm like, wow, this is great. Because the typical pattern is people use the Tableau desktops to like probably download the extract or put it on some cloud file, and then they use the Tableau desktop to do this process of creating the extracts and then pushing it to the Tableau server. So even the developers are like kind of, they have lost productivity because they're waiting for this whole process to finish, sometimes using their own laptops. So instead of that, here, all the processing of the creation of the Hyper file happens on Databricks cluster. And as part of the same ETL pipeline, we are pushing it to Tableau, which is amazing. So the reason some of my customers got super excited is because they are creating a curated data lake, right? Because they have structured data, unstructured data. They want to convert some of their batch ETL jobs into streaming ETL jobs. And as you all know, Spark and Databricks does an amazing job with streaming as well, right? So they were creating a raw layer, then a silver layer and a gold layer. And then the patterns for egress were mainly about, like, we have very good Tableau connector. So one pattern is for data exploration and data science kind of purposes, data discovery. They connect directly to Databricks and do their dashboards. But they had a requirement where a lot of the dashboards were going to like executives, and they want like millisecond level latency, under 1 second. And so in that use case, Hyperloop library that Will developed is a great fit, because no matter whether your data is in a data lake or a data warehouse, from Tableau, when the dashboard runs, if you have to go through that ODBC, JDBC connection, there's always latency. You're going over the network. Here, you're putting your most critical millisecond level latency dashboards. You're putting it in Tableau as an extract, so the data is already there. And then your dashboard loads super, super fast. So it's a great pattern which plays on top of the data lake and the lakehouse pattern for the faster dashboarding. So
that's awesome. So let's talk about the different ways that you can connect Databricks and Tableau a little bit, because there is connectivity, and what we've been talking about a little bit is the kind of the pain that you get with ODBC, JDBC, is that you essentially in the cloud, you have the network to contend with. And in the cloud, the network is the internet, right? And routes are kind of, up in the air, depending on what you're going to get. And data locality, it's important now, right? So data has gravity, and you want to process it where it is. And kind of the different types of ways that you can access the data is either using Databricks to perform ETL, which Spark is a great ETL engine. Delta Lake brings the file formats and the extensibility to the APIs to make that type of work very simple. And then there's also connecting directly with the Delta engine or with Databricks itself. And this is what we're talking about with the ODBC connection, where you're connecting Tableau to Databricks itself, and then that's connecting to your Cloud Object Store. And there's all these efficiencies that's built into that connector. And even our BI team has spent a lot of time making that connector better. There's even a Databricks connector with inside Tableau now. And with stuff like Delta caching, the experiences have gotten better. But as you guys have seen in the field, requirements are getting more stringent. People want the latency of the data, so the data freshness. right? How fresh is this data? And then do you have the problem of scheduling? So have you guys seen that out in the field where now scheduling or orchestration between these systems has gotten simpler? And can you talk about that at all? Or do you have any stories about how orchestration gets simpler?
Yeah, I guess I could take this one. So, you know, basically by leveraging this Hyperloop library and to create these data extracts a lot faster, you know, what you could do is in your ETL pipeline that might be continuously running, you could tack this as an extra step onto the end of your pipeline. So after you've created your CDC and you've merged it using Delta Merge, you can now take that and basically create an extract and push it to Tableau Server.
Oh, that's awesome. So essentially, if you have like schedules on Tableau Server for extract refreshes and you have your ETL schedule, I know it was a big pain for me back in the day when I was trying to manage like warehousing refreshes and Tableau refreshes, that you kind of have to manage overlaps, right? And maybe put some buffer. And then all of a sudden, if one day the server gods were shining down on you poorly, and the server, you know, everything wasn't moving along, your buffer went away, and maybe your schedule missed, right? And your ETL didn't finish for 2 hours later than it normally did, but your extract refresh schedule now overlapped, and now it causes pain and latency. So it's an extra thing to track down. Tacking on this process to the end of your ETL pattern seems like a pretty good architecture pattern if you're trying to decrease the total amount of latency in your end-to-end pipeline.
Yeah,
So,
Actually, oh, sorry, I wanted to chime in real quick just because we had a couple comments on LinkedIn Live. So one of the call outs, do me a small favor, Franco, if you can just scroll up back to the original, to the other slide. Perfect. There you go. The use cases. There was a call out on LinkedIn Live about the fact that why aren't we talking about live queries? And so we did want to emphasize the point that no, you absolutely can do Tableau live queries against Databricks. Exactly what Franco's currently circling. Okay. This is for the case where we're going to be extracting out millions upon millions of rows, right? That you want to bring down to Tableau for scheduled extracts for whatever process that you want to do downstream, as opposed to do live queries. There's some situations where live queries are extremely appropriate. And exactly, you can connect to the Delta engine directly. There are some situations where you're going to need to do extracts, especially scheduled scenarios. And so in this case, what today's session is very much on that scheduled extract scenario for those situations. Okay, just wanted to clarify that.
yes, exactly. Thank you, Denny. Thank you for monitoring out there and making sure that we're on track. Yes, absolutely. You can connect live. You know, Will, do you have any examples of where connecting live didn't fit the bill?
Yeah, so if you want to create a notebook basically or a workbook within Tableau and you want to basically you know, create a data extract, that might not fit the bill. Or if you have, you know, a really large data set where you know, your query might take a very long time, and it'd be better just to create a data extract, kind of break off a piece and do your ad hoc visualization on your own end. That's kind of where you would want to you know, fall into the category of a data extract and using Hyperloop to speed that up.
Or if you have like queries that return a lot of rows, for example, and returning a lot of rows over the wire can be a bit slow, right? Even with the modifications that you know, we've been working with, our BI team has been working with Simba and Tableau to make it faster. So like a Arrow, for example, Apache Arrow has made the overall transport much faster. You still have to contend with the network and the internet, for that matter, if you're going over distance, right? If you're egress into another region or something like that. This allows you for more to put the data where it's supposed to sit for better performance. So for example, you're using Databricks where the data sits in the data lake to prepare the Hyperloop extract file. So you get all the data together, and then you transport it over the wire to Tableau Server so that the data locality is more local to where you're going to be using it. So the data in the data lake sits on Delta Lake in, you know, the cloud and the data center on its side. Tableau might sit in the cloud. It actually might sit on-prem, right? Have you guys seen instances out there where Tableau Server, it could be in cloud or could be on-prem, and so you want better connectivity to your on-prem Tableau Server?
Yeah, I've definitely worked with a few customers, especially in the federal regions where their Tableau server is on-prem, and basically, this allows you to bring kind of the processing closer to the data and speed up those extracts.
Awesome. Well, let's get into it. Let's start playing around with it and see how to make this work, right? We've seen enough. We've talked about it a little bit. What I prepared today, I have a pretty extensive demo that goes through how to create Delta tables using this specific thing uses TPCH. They normally use it for benchmarking. It's just sample data. What I've done here is I've created a metadata database on Databricks, and I've put all of the data, the tables in there. And now we're going to use Hyperleaup to extract that data and send it over to Tableau Server, where we have a dashboard waiting for us that we're going to kind of show how this stuff works. So we're going to be using this database. So I'm using primarily SQL commands here. There is going to be a little bit of Python when we get into Hyperleaup, but I want to kind of explain how you can use primarily SQL to do a lot of these things. And you can see Will and Soham are going to be in here kind of working with me to help me figure out how to get this stuff to work. So I'm going to set the context, right? And any SQL editor, you have to use the database that you're currently in. So I'm going to say use this demo database that I've created here. And then I want to see how many rows we have. So here I've got about 29 million rows that I need to get over. Just for the audience sake, if I were, your experience-wise, Will and Soham, if we were to do something like this on Tableau Server and have to extract 29 million rows over the wire, do you have any examples about how long something like that would take?
Yeah.
So go ahead, Soham, please.
Oh yeah, typically this like if you are going to do an extract like which are 10 million, 20 million record plus, it could take hours, like literally 2 to 3 hours. Like we have customers where they have scheduled all these extracts, they run for hours, and the Tableau backgrounder is like just super slow beyond a certain point. So.
Wow, that seems like a long time, especially when you think about like the total amount of time that it takes to kind of derive an insight, right? And to be able to work with it. 2 to 3 hours can be a long time in today's world. So that's interesting. So what I'm doing here, I got 29 million rows, and I'm going to be just taking a sample of the data. So this is what it looks like. I'm going to be adding a process date on it. I'm going to show you a little bit later how you some interesting functionality with Hyperleaup, where you can append data. I'll kind of show what that looks like, but I just want to keep track of when this data came in. So I'm just going to add a process date to that. This is what my data looks like. It's bunk data, right? It's to kind of just sample stuff that it doesn't really mean anything, and a lot of it is repetitive. The important thing here is just know that it's data, right? It's a lot of data, and we're going to be transmitting it over.
And one thing I would love to add, Franco, as if you scroll back up just to add that cell, you'll notice that basically in all of our examples here, we're using good old-fashioned SQL, and we're treating everything in the traditional, almost like data warehousing style queries, right? In other words, what you're used to within that realm of running SQL and database, relational database style, it all comes into play. This exact same example, everything about it. So just wanted to call that out for some folks who are wondering, hey, we're using Databricks. Aren't you supposed to use Scala or Python? Nope. You can very much use SQL and be a database guy like me. I'm a former database guy, and jump right in. Sorry, just wanted to chime in on that.
Thanks,
Hey, Franco, can you click on the comments tab, please? At the top. Yeah, I added a comment. I want to see if, yeah, right there. Oh, there you go. So
that's awesome.
Here's an example, right, where you can like develop as a team. So in this case, Franco is developing some queries, and maybe we are doing some code review, or we are developing together in different cells, but you can probably, I can go ahead and change the code. I can put some comments, and then we can work in a collaborative fashion.
That's awesome. Thanks, Soham. So you guys can see at the top, y'all can see at the top here, there are 2 color boxes. One, and it's got their initial W and S. If I hover over it, I can see who they are. I got Will, Girten, and Soham Bhatt in this notebook with me, and we're essentially collaborating together. And Soham can modify code and leave me comments about stuff I'm doing silly or I'm not doing right. And we can kind of review those and collaborate. It's awesome. Thanks, Soham. So what I'm going to be doing next is, and feel free if either of you want to, take over and start explaining things better, because I put this stuff together late last night. Anyway, so we need to configure Hyperloop to work, right? And to do that, we're going to be issuing a couple commands on the driver node. And I do that in Databricks by issuing the magic command sh, %sh. That essentially allows me to run commands on the driver node. And I essentially want to install the Hyper API. Will, do you want to tell us a little about what's going on here?
Yeah, so this is just basically, we jumped into a shell into the driver node, and basically what we're doing is installing some of the dependencies. Like I said, under the covers, Hyperloop really leverages the Tableau Hyper API, and it allows us to create a Hyper file locally on this driver node.
Awesome.
Yeah, and I also want to add that, this Hyper file thing, these are Tableau Hyper APIs. So a lot of folks may not be aware of this, but if you remember in the old days, Tableau had like this TDS files or TDSX or Tableau extracts. They are essentially upgrading that TDX file to a Hyper file format, which is like a columnar compressed file format native to Tableau. And what Will is doing here is creating a library, and we are all using the Tableau standard Hyper APIs, right? So just want you to know that this is the standard best practice suggested by Tableau, which is the Hyper APIs.
Thanks, Soham. Absolutely. Actually, funny story. I was at the Tableau conference the year that they announced Hyper, and my favorite song from Scooter, Hyper Hyper, was playing on the speakers almost the entire conference. It was epic. But funnily enough, the Hyper team, which is from Germany, which if you know anything about EDM, Scooter is from Germany. And I'd asked the guys, I'm like, so you like Scooter? And they were like, no, I don't even know what the song is. And I was like, so let down. Anyway, so what I'm going to be doing here is creating the Hyper file. So I'm going to go to the Hyperloop package. I'm going to say import the Hyper file command so that I can create this. And what I'm going to do is I'm just going to put SQL into that query. I'm going to kind of put it into the variable query. And it's the same SQL command that I had run up here just to kind of see my, my data. I can see my data inside Databricks. That's the data I want inside Tableau. So I'm just going to copy that SQL statement here, put it into a variable, and then tell the Hyperfile command, I want you to call it tpch extract. That's what we're dealing with here. That's my query. Will, do you want to tell us about these two commands here?
Yeah, sure. So at the core of everything, just like you were, run this on a Tableau desktop client, you're going to create an extract, and at the end of it will be a Hyper file. So this is the main kind of object here. And basically what DBFS enabled flag does is it tells the Hyper engine that basically, the file system is a Databricks file system. This can, can easily download this and run this on, any EC2 instance or, locally on your own computer as well. And you basically would say, you'd flip that flag and say it's just a local file system. And then creation mode. Basically, there are two creation modes within the Hyperloop library. One is a little bit more friendlier to things like null values, and that's insert. So basically what it does is it inserts one row at a time into a Hyper database, the Hyper file. Or, the most efficient way, if you have a huge extract with, many millions of rows, is copy. And it basically does a bulk copy from basically a CSV into the Hyper file.
Interesting. Thank you very much. That's quite some extensibility there. So when we were talking earlier about how long this stuff would take on like Tableau Server to extract itself, we were talking hours for like 29 million rows, right?
Mm-hmm.
All right. So in this example here, I did some configurations, some special, performance tuning. Are they hacks or are they tricks? I don't know what you call them, but I kind of took my knowledge of what was going on with this project here, and I created a special cluster for it. And I actually got it to create the extract file in like 8 minutes. You can see here. This command for 29 million rows took 8 9 minutes. Now I then want to transfer that data because right now it's on the driver node, right?
Correct.
So we can also save that by using the save command, right? So if we wanted to persist that extract file, what command would I use to do that with HF there?
Yeah, correct. So the Hyperloop API has a couple handy functions within it. So, right now, like you just said, Franco, the hyperfile is currently written to local disk on this cluster. But if this cluster is ephemeral, it gets shut down, and basically your hyperfile is gone. So I have a function there called save, where you could basically save this to DBFS or S3 in this case. And come back the next day, load it up, and then append new data as it arrives in your Delta Lake to this hyperfile. So you don't have to go back and recreate it every time. You can save it, persist to the cloud storage, reload it, and then append new data as it arrives.
Interesting. So I can just save this to DPFS into like my local data, and then, or I can persist it to any object storage. So let's say ADLS or S3. And then if I wanted to kind of keep this up to date, I could then append new records to that extract file and then transmit the new extract over to Tableau.
Exactly.
Oh, that's awesome. Let's try that out.
And that's a killer feature right there, right? Because a lot of time people are used to just create entire extracts and then, like do a full load to Tableau every night, let's say.
Yeah.
Once they discover this, customers love it because now the extract, let's say your day 0, day 1 load is on DBFS. You're just doing the daily increment appends to it, and then you're publishing it. So massive saving in terms of your ETL pipeline. It's almost like a CDC into Tableau, which is super cool. Wow.
That's awesome. So let's talk about users a little bit and scale. What have you seen in the wild? How big does this scale to?
It could scale pretty well. So I have a customer that has many concurrent Tableau users, several thousand in fact. And what this does, by moving this processing closer to the data down in Databricks, we can basically use the leverage Databricks clusters to auto scale out and really solve that bottleneck problem that we saw earlier with the Tableau backgrounder that couldn't really accommodate all these concurrent extracts at once. So, this particular customer I work with, they have several thousands of concurrent Tableau users. Basically we can leverage Databricks clusters to auto scale out and handle that load.
That's awesome. What have you seen out there, Soham?
In my case, like the customer had like around 150 Tableau extracts, and they were managing it all via desktop. And now suddenly, they totally love this library because now they can, first of all, automate the entire schedule. That's one advantage. And once the extracts were fed, they had around 500 or so Tableau users that were using this.
That's awesome. So I know that back in the previous slide, that the backgrounder is on the same server as it's used to actually serve the dashboards. So people trying to get to a dashboard that's on the server could actually be throttled by the background, the extract processor running. So this could actually help alleviate stress on your Tableau server so that you could get more people concurrently running. Is that right?
Exactly. You could definitely scale out, up there in the Tableau server, but it's not as easy or cost effective, in my opinion, as doing it down in Databricks.
Sure, when you can just pay for whatever you use.
Yep, exactly.
Awesome. So I just want to take a look at this. So we said on Tableau server, 29 million rows, it could take hours, in the order of magnitude about 3 hours to do a refresh over the wire. And just to show you what this took, it took 9 minutes to prepare the hyperfile. And then to transmit it to Tableau over the internet, it took about 4 minutes. So in the matter, 13 minutes compared to 3 hours is significantly better.
I think so.
Yeah, and to your point, all this was happening initially on Tableau server, right? And now you have essentially taken a big part of the processing to Databricks. You can run it in parallel on ephemeral clusters. So you get the job done, you shut down the clusters, right? So much more efficient compared to doing it on the Tableau servers.
Awesome. And then now let's just say I want to do an incremental refresh, right? So I've got data constantly coming in. For here, I'm just going to emulate it, but I'm going to create another data frame of my data that I previously had, but this time I'm going to change the process date to 10/20. So this is today. I processed yesterday's data, but now I'm going to put today's data in there. And I'm just going to sample this down. A very common function that I like to use in the field is sample when just working with scales of data. By the way, funny story, you can actually do this to beef up a data frame. So if you're trying to test scale on Databricks, you can arbitrarily increase the size of a data frame as long as it's a decimal. So it has to be 10,000.1. You can't put 10,000 in there to beef it up by 10,000%. It has to be a decimal. So just, life pro hacks there, life pro tips. Just in case you ever want to arbitrarily scale a data frame to test, I don't know if you can push 100 terabytes through Delta, if you want to do it. Anyway, so here I just basically grabbed, I don't even know what that is, 0.00, is that a millionth, a hundredth, a thousandth? Anyway, I'm off on my math. And I want to just sample it down, just a couple hundred rows, and then I want to append it. So I appended the data frame to that, and it only took 25 seconds to basically do a daily increment to my file. And then what I could do is I can then take that hyper file and then retransmit it over. Oh, hold on. There we go. So I can then take my hyper file that I had just configured, just appended new rows to, and I can send that back over to Tableau Server. And that's what's happening now. So let's take a look at Tableau. Here is the site I created for this, and this is a sample dashboard of TPCH data. I know it looks very homogeneous, and there aren't very many outliers. This is sample data, right? It's emulated data, so it's not really going to show anything. If you have any ideas on how to make this look more interesting, I'm really open to them. But anyway, we'll take a look here. And essentially, when I loaded my extract file, it got put here to my extracts. And this is where I can see my extract file. So my extract loaded from Databricks into Tableau, and this is where it is. And now I can start working with my extract file on the fly. And I basically sent that over with Hyperloop. So this is the Delta Lake to Tableau Hyperloop Express, as I like to refer to it as. So with that, Denny, I think we want to open it up for, does anyone have any other remarks before we kind of open up to questions here?
No, I think it's just really nice. So let's just dive into some questions. I'll start with Zoom, and then I'll switch over to LinkedIn Live. The first question actually that they end up asking on, first call out on TPC was that TPCH is really boring. So that's true. That's actually completely fair, and we got no problem with that. So that's fair. But we actually now have an actual technical question, and I'm going to direct that to you, Will, since you had helped. This is your project.
Sure.
What is the size of the hyperfile? Out of curiosity, like, does it do any compression as you're basically, for example, that 29 million rows that was initially extracted? Was there any compression involved, or is a lot of the reason for that 3-4 minutes transfer just because of the fact that it's such a large file being copied over?
Yeah. So with regards to the actual core technology, it's proprietary format, Tableau's Hyper format. You could easily create another collab lab on it. But basically, it's very similar to Parquet, I would say. It's column restore, it has better compression. And for a file this size that was created by Franco, you're looking at the order of a few megabytes.
Good stuff. That actually absolutely answers our question. And then the next question, does the library support upsert, delete, and insert to create an incremental extract using newly updated rows only? Or is it append only right now?
Yeah, that's an excellent question. So currently, it only supports append. However, the future roadmap will support upserts in the future. So you'll be able to do things like deletes, updates, and inserts. This is a library that I've created in my spare time. So it's really just, development life cycle for this is really just the fruit cycles that I have. Yeah. So, but upsert is coming.
Perfect. Actually, Franco, why don't you show, since you happen to have the link there on the Goodwill Punning, Will's awesome. I love the name of your GitHub repo, dude. Goodwill Punning. That's sweet. Yes. And so basically, as Will called out, here is the code base. It explains why hyper extracts are so slow in the data extracts are so slow. So all the explanations is all here. Take a look at it. You can understand more. And exactly like Will called out, if you have either any feedback or would like to do a PR, because after all, we'd love your input, right? Go ahead and actually chime in here, right? So we also have some quick logistical questions, which is, can we get a replay of this webinar? So for anybody that actually wants to watch this webinar, it's actually okay, because we have this already posted to YouTube live as we speak, so you can watch it there. And at the exact same time, we're posting this on LinkedIn Live as well. So in fact, we're monitoring all the questions. So if you have any more questions, by all means, please chime in here. We're looking at, like I said, we're looking at Zoom. We're looking at YouTube Live, and we're looking at LinkedIn Live. And say that 3 times fast. All right. So I'm going to continue. Right now, I'm just trying to see if there's any other questions. Anything, meanwhile, Will, Soham, you'd love to add as I look for the questions, that is.
Well, I guess I'll say, I'm thinking more about, like, with Malcolm Gladwell and all the reading, like, I'm thinking more about, like, happiness quotients, right? So what are the personas that make, that are, like, happy with Hyperloop, right? So the BI developers are happy because they don't have to use Tableau desktop to do all this, right? The data engineers are happy because directly from Databricks, they can write to Tableau, right? It's all automated. Tableau admins are happy because we are helping them reduce the load on the Tableau server. So I thought I'll just put it out there. It's all about spreading happiness.
That's awesome.
That's a great call out. Sorry, go ahead, Franco. I apologize.
No, that's absolutely right. I love it. This is why I really do enjoy working here at Databricks. And let's segue into that. If you are currently looking for a new adventure, here at Databricks, we are hiring. So if you're interested, feel free to reach out. We're always looking for good people to join the cause and to help us solve the world's toughest problems. Just like Will here created this awesome project, and Soham and I are out there trying to help the good people, the good data people out there, figure out how to find value in their data faster.
Oh, and before we, oh, sorry, go ahead, Soham. I did not want to interrupt you, buddy.
Oh, no, it wasn't me. Was someone else trying to speak?
I was
sorry.
say, not just faster, but simpler.
Good call out. No, I was about to say, I wanted to end, before we transfer to Karen, I did want to call out exactly to your point. Since you're all into vidcasts and podcasts, don't forget, because Malcolm Gladwell is speaking, back to that, Revisionist History, excellent podcast. It is very, very enjoyable. So I highly, highly advise you guys to go listen to that. So with that, I think we've answered all the questions. Will, Soham, thanks very much for this awesome session. Franco, amazing demo. Thank you very much. This is awesome. Karen, why don't you close up shop for us today? Thank you very much.
All right. Thanks so much, Franco and Denny, and thanks, Will and Soham, for joining us. And thanks everyone for attending. So I'd like to direct you to the YouTube Live. So if there's any kind of outline questions, please drop them there in the comments once this broadcast is over. And thanks everyone for joining us. Hope you all attend our session next Tuesday, and use that code for Summit. We'd love to see you there. Some great speakers. So with that, I'll wrap things up, and hope everyone has a great rest of your day. Thanks so much. Take care.
Thanks, everybody.